let's go ahead. So now let's go classic. So I need to calculate the sum of all elements, classic. So I need to calculate the sum of all elements in L. Of course, the answer will not get S is equal to L. So the answer is S. Or you ask it as a question, is S the sum of all elements of the list L? Of course, I will draw the list L. And let's say break it down into head and a tail. So of course I apply it recursively, and when I apply it recursively, what happens? Sum head tail S. So S is the sum of the list with head H and tail T. If so, what do? I first apply it on the tail, and I get the sum of all the elements of the tail, ST. So ST is the sum of all the elements of the tail. So I say this is satisfied only if ST is the sum of all the elements of the tail. So I get ST, the sum of all the elements of the tail. Now the answer is just head plus ST. So I say S is because now unfortunately I have to add H to ST. The sum of all the elements of this list is sum of elements of all the elements of this list ST plus H. So I need to perform arithmetic. So equality is the Java equality. It checks if they point to the same object or not if they are numerically equal. Is when you say they are numerically equal. So the answer is S is ST, the answer of this, plus H. Let's take it down. So sum of HT S is sum of T is ST and S is ST plus H. And I did not define the base condition, so let's define the base condition. Sum of an empty list is always 0. You don't need to do anything about that. So 1, 2, 3 is S. Oops, it's a fact. Oops, it's sum. Yeah, so it's 3 plus 2 plus 1, 6. And do not even try the other way around. I'll let you know what happens. Make a list such that the sum is 45. Arithmetic will have to be careful. Prolog cannot do arbitrary addition. So it cannot do arbitrary addition. Try solving this program by backtracking yourself and see that you need an arbitrary addition. So Prolog cannot do arbitrary addition. It can only do addition when both the operands are given and you just need to calculate the sum. You cannot invert it up where the sum is given and you say what are the operands. Prolog cannot do that. So that was obvious. Let's say sum of all positive numbers. So of course I'll add in a condition around over here. So sum of all positive numbers with head H, tail S, the answer is S. So I recursively do it. I first do it as the sum of all numbers on the tail, sum positive, T comma ST, and now there are two conditions. If head is positive, then the answer is S is ST plus H. On the other hand, if the answer is negative, so I could have used semicolon, let me define it for the negative case as well. HT comma S. If head is negative, then of course the answer will be S itself. So S is ST, and an interesting way to write S is ST is when you can just write it down as here. So S is ST, and the base condition, of course, sum positive, empty list has a sum 0. That's always just satisfied. That's Prolog. So I'm not sure if I should be writing it up, but let's do it. Sum positive, head, tail. Let's write down the base condition first is 0, of course, and sum positive, HT has a sum S, if and only if I first do it on T to get ST, and if head is greater than equal to 0, the answer is ST plus H. And of course, I will have the other condition as well. So let's write it down here. On the other hand, the answer is less than 0. Then the answer is just S. So sum positive 1, 2, 3, 4, 5. The answer is S. $15. And if I add a few negative, it is, oops. Okay, so the answer is definitely not 3, and yes, that's the problem. Okay, let's do it again. Yes, that's 9. 5 plus 3, 8 plus 1, 9, and there's no other substitution possible. Again, I won't do it up the other way up as well. So that was a sum of all the positive numbers of this thing, and let's do it. Let's say another example. So what do I do? Positive. So let's say that I have a list 2, 3, 5, 6, 7, some negative, and I need to make a new list which has only the positive one, so that will be 2, 5, and 7. So I say that positive list L1. So after deleting all the negative elements, L1 is the list consisting of only the positive elements of L. So this is my answer and this is my input, and there's only one input, one output. Of course, it's Prolog. I'll ask it more or less as a question, and I'll say that is L1 the list after considering only positive elements of L? I love figures, so let's write down L. And of course, we'll solve it up recursively. So let's have a head, let's have a tail specific to L. And I also have my answer list as L1. So L1 will have a head and L1 will have a tail. This is my answer list. I'll do it two ways. One considering head is positive and the other one considering that head is negative. And in both cases, my recursive call, I'll assume that anything which is recursively called could happen as it is. So let's consider the cases one by one. My case 1 is when H is positive. So I say H is positive, and in that case what I need to do is H will definitely be a part of the answer. So I've got my answer list, the head specified. And for the tail, of course, I'll call it recursively. So from the list T, if I only take the positive elements 0 included, I get L1T. And this is my definition of pos L. L, which is HL, and okay, let me write it down, giving me some more space. Pos L, HL, TL, and H1L, T1L, and of course L1H is equal to H. Let's put it here only. So this is just H. It was HL. Oops, it was H. So head, tail, and of course, let's do it again. So this was my answer list L1, and I say H1 and tail 1. So if head is greater than 0, then I have H1 is equal to H, and H1 is equal to H. I'll just write it down over here. And otherwise, my tail 1 is a result of calling the positive on this tail over here. So let's just write it down directly. So positive list head tail gives me a new list with the same head and a new tail T1, where the condition is only applicable for positive H, 0 included. And all I need to give is what is T1. This is T1. And similarly, you can write down for the case when H is less than 0. What really happens is you do not append H. So I will still draw it up, although I have written down the code itself. So if H is less than 0, this is my input list, H1, T1, sorry, HT. And this was my list L, and this is my answer list, which is H1, T1. And all that I do is over here, so if H is less than 0, then of course I will have a new list, which is this L1, and my L1 will be nothing but, so you can forget H and do everything on T. So pos L, T. So if I apply this thing, it gives me the new list L1. H1 is not to be considered itself. And in a fancy, so that's a condition of pos L, HT, L1. And what you see is what is exactly the same thing written with a change of the variable names. So L1 and L1. And remember, it's all, so it's either the previous one or the new condition, and the base condition is, of course, it's pos. If I get an empty list and I do whatever I need to do, make a list out of it, of course my answer will be empty list. Input empty list, output empty list. So positive 1, 2, 3, 4, 5 gives me a new list L. Answer is 1, 2, 3, 4, 5, of course, and there is no other answer possible. Let's add a few negatives. and run that up. So the answer is 1, 5. These were the only positive ones over here. So that's when I say that I need a sublist which has only positive elements.